Hi girls, this video is going to cover our section 1.7 material, so the content that we need to get through on Thursday while I'm out at the senior retreat. And this will cover information about absolute value inequalities. So we're going to take what we learned yesterday and build it up one additional level so we can work with absolute values not only in equations but in inequality form as well. So you want to make sure that you have a notes packet from the front of the room. And then we're going to go ahead and get started with a warm-up problem where we're taking a look at the type of material that we covered yesterday. So we're going to go ahead and start off with this one where we have an expression or a coefficient out in front of the absolute value sign. So to get started here, I'm not able to distribute that 2 inside of the absolute value. So instead I need to divide both sides by 2. That's going to give me the absolute value of 2x plus 12 being equal to 4x. Then to solve any absolute value equation, I'm going to break it up into 2 different parts. So I'll be left with 2x plus 12 is equal to positive 4x, and 2x plus 12 is equal to negative 4x. So I have those 2 equations to solve. I'm just going to solve each one like I would any other algebraic linear equation. So I'm going to subtract 2x over on this side, subtract 2x here as well, and I'll have that 12 is equal to 2x. At that point I can just divide by 2, and my x value is going to be equal to positive 6 here. I'll do the same thing over on the right. I'm going to subtract 2x on each side, and I'll have 12 is equal to negative 6x if I'm subtracting 2 more from the negative 4. At that point, I divide both sides by negative 6, and this x value is equal to negative 2. So I have these 2 solutions here. But if you remember from yesterday, we needed to make sure that we not only solved through, but then we took our values and plugged them back in. The reason that we want to do that is that we could end up with an extraneous solution or an extra solution that's not true. Now when we plug back in, we can either use the original equation that we have here in blue, or we can just plug into the equation that we have where we divided the 2 out. And that's probably a little bit easier just because there's less going on. So I'm going to take this 6 and plug in up here for anywhere I see an x. So that's going to give me 2 times 6 plus 12 in the absolute value is equal to 4 times 6. 2 times 6 here will give me 12. 12 plus 12 is going to give me 24 in absolute value bars. On the outside, I've got 24 as well because that's 4 times 6. The absolute value of 24 is just 24. So that is a correct solution. So I'm going to hang on to that x equals 6. Then we'll take a look at this x equals negative 2, and we'll do the same thing and plug it in to this expression over here for anywhere that we see an x. So I'll have 2 times negative 2 plus 12 is equal to 4 times negative 2. And then I can simplify. 2 times negative 2 is negative 4 plus 12 inside here. 4 times negative 2 is negative 8. Then I'll have 8 in absolute value bars is equal to negative 8. And I'm encountering an error here because if I try to take the absolute value of 8, it's going to be a positive number, not a negative number. So this value here is not a solution, it is extraneous. So that means we're not going to report it back as an answer to that problem. So that's our approach for solving basic absolute value equations. Anytime there's anything algebraic going on outside of the absolute values, we definitely need to make sure we're plugging back in. So let's go ahead and move on down to the next problem involving absolute value equations. And this one I really just want to focus on to see what we want to do in terms of dealing with negative and positive pieces of the right-hand side. So this one we don't have any coefficients that we have to work with, but we do need to break it apart into 2 different equations. We'll have 9 minus 2x, that stays the same, and then the positive value, all of my signs stay the same. I'm also going to have 9 minus 2x is equal to, when I take the negative version of the equation, I need to make the entire right-hand side negative. So negative 10 plus 3x. And then I'm going to solve those 2 equations. So over here, I'm going to combine like terms on the left. I'll start off by adding 2x to both sides. So that's going to give me 9 is equal to 10 plus 5x. Then I'll subtract 10 on both sides, and I'll have negative 1 is equal to 5x. I'll divide both sides by 5, and so my x term is going to be equal to negative 1/5. That's one of my possible solutions. I'm going to come and do the same thing over on the right, so I need to make sure that I distribute that negative, and that's going to give me negative 10 minus 3x. So then again, I want to start combining like terms. I'm going to go ahead and add this 3x over here. So I'll have negative 2x plus 3x. That's going to give me positive x. And then I've got a positive 9 here is equal to negative 10. I want to go ahead and subtract that 9 here on both sides. So that's going to give me x is equal to negative 19 if I'm subtracting both there. Sorry, that looks a little bit funky there. So my final answer here is x is equal to negative 19. Now at that point, I need to take both of these solutions and plug them back in. One's a fraction, so it's going to take just a little bit more algebraic work. So let's go ahead and start by plugging in this negative 19 to my original equation. When I do that, I have 9 minus 2 times 19 in absolute value bars is equal to 10 plus 3 times negative 19. So then at this point, I want to go ahead and figure out what those expressions are going to be. So inside of my absolute value bars, what I am going to find is that if I multiply the 2 times 19, inside my absolute value bars, I have 9 minus 38. Outside here, I have 10 plus 3 times negative 19. So that's going to give me 10 plus, and then 3 times negative 19 gives me 57. So here I'll have 10 minus 57. Inside my absolute value bars, when I take 9 minus 38, I'm going to get the absolute value of negative 29. And on the outside here, I'm going to get 10 minus 57, which is going to give me negative 47. Now, these two sides of the equations are obviously not true. So this expression is going to be an extraneous one. Then we can go ahead and come over on the left-hand side and plug that value back into the original expression. So here, I'll have 9 minus 2 times negative 1/5 in absolute value bars is equal to 10 plus 3 times negative 1/5. Now, we could either use our calculators to make a quick approximation with decimals, or we could work with fractions throughout. Because this is just a quick check, it's okay to use your calculator. So if we were to input what is inside the absolute value bars here, if I plug into my calculator 9 minus 2 times negative 1/5, I'm going to get the absolute value of 9.4. If on the outside I take 10 plus 3 times negative 1/5, I'm also going to get 9.4. So check this in your calculator or do the fraction work by hand and make sure that you can get that same final answer. Because this works out, this is the correct final solution, and I'm good to go there. That one was a little bit nastier looking, I would say, than the first one just because of the fractions, but our process is exactly the same as we go along. So let's go ahead then and take a look at how the things that we want to discuss today are different. So the values that involve absolute value inequalities instead of equations. So we've got our first example here, and this one's pretty easy to get through. It should feel pretty similar to what we were doing when we were solving our original inequalities. So when we're looking to solve absolute value equations and inequalities, we always need a positive piece or positive component and a negative component. So here, I'm going to break this up first into the positive component. I'm going to take 6x is less than positive 18. Then I'm also going to have the negative component. So 6x and negative 18. Now when I take the negative side, I need to flip the sign. So this is going to become 6x is greater than negative 18. Now I want to go ahead and divide both sides by 6 here. So I'll end up with x is less than 3. Over here, I'll divide both sides by 6, and I'll have x is greater than negative 3. So the values that will make this absolute value inequality true are going to be in between 3 and negative 3. So because a value can be both less than 3 and greater than negative 3 at the same time, that makes this an and inequality. So if we think about that on a number line, either before we've put it together in a compound inequality or after, all that we want to think about is, okay, first we find negative 3 on the number line, we find positive 3 up here, and we know that we want our values to be less than this 3, but bigger than that negative 3. So I would shade what's in between those two quantities. Now both of these signs are going to be open circles because they are less than and greater than, not less than or equal to or greater than or equal to. So the key takeaways for your absolute value inequalities are that you still need two different pieces. When you take your positive piece, you leave it exactly the same, you just remove the absolute value bars. When you take the negative piece, you have to flip the sign and then make the term on the right negative. When you get to your two final results, you might have to think through a little bit what your final answer is going to be in terms of how you report it back. So I always want to ask myself the question, can I be both less than 3 and greater than negative 3? If that's the case, then I know that I'm reporting back an and inequality. And it's always a good idea to check your work. So in this case, I could pick some value in between negative 3 and 3, like 0, and I could plug it into the inequality. So if I did something like 6 times 0 is less than 18, I would get 0 is less than 18 because the absolute value of 0 is 0. That checks out, so I know I have the right range of values there. So let's try a few more of these where we're taking a look at some slightly more complex inequalities along the way. So go ahead and scroll to example 2. And with example 2, we're going to do things exactly the same way, but we're just going to perform some preliminary steps before we separate things out. So for this one, I'm going to begin by adding 2 to both sides. So that way the absolute value is completely by itself on the left. So I'll have the absolute value of x minus 2 is less than or equal to 12. Then I can go ahead and break that into 2 pieces. I'll have x minus 2 is less than or equal to positive 12, and x minus 2 is greater than or equal to negative 12. So I'm flipping that sign. Then I'm just solving from there. I'll add 2 to both sides here and have x is less than or equal to 14. Over here, I'll add 2 to both sides, and I'll have x is greater than or equal to negative 10. Now notice I can be both less than or equal to 14 and greater than or equal to negative 10. So I can rewrite this inequality as one single piece where my x value is in between the two bounded values, the lower and the higher. If I want to graph this on a number line, I would find negative 10 down here, positive 14 up here. These are both going to have shaded in circles because they're less than or equal to, and then I'll fill in between. So then let's see what other kinds of combinations of information we could come across. Our next absolute value inequality problem is going to have a coefficient in addition to having one step that we have to take at the beginning to isolate the absolute value. So with this expression here in example 3, I'm going to begin by subtracting 8 on both sides. So what I end up with here is 4 times the absolute value of 6 minus 2a is less than 16. Then just like we saw with equations, we want to get rid of the coefficient in the front. So I'm going to divide both sides by 4. And in absolute value bars, I'll have 6 minus 2a is less than 4. Then here I'll go ahead and break that up into 2 separate inequalities. I'll have 6 minus 2a is less than positive 4. And 6 minus 2a is